Hi everyone, this is my video demonstration for Project 8. This is at least my first attempt at a demonstration. I'm going to carry out this demonstration without my quadcopter flying, just because I don't want to risk breaking things before getting a video. And then here in a little bit I'll try to get one while it's flying. So for this demonstration we were supposed to use a sensor connected to the Arduino mounted on the quadcopter to capture roll, pitch, and yaw of the quadcopter and send that via serial over USB to a Raspberry Pi, and then send the data over Wi-Fi from the Pi to a host and then display that on the host. So I'll show you my setup here, sort of similar to the last couple of projects. I have my Raspberry Pi mounted down here. I moved my power bank to one of these arms, which probably isn't the most stable, but I had trouble getting everything on here. I have my Arduino attached to the top of my Pi. Still have the camera on my quadcopter, and the GPS is down here. So here is the sensor for getting the roll, yaw, and pitch. It's the Adafruit EN.605.715. The one that came with my kit just had a bunch of like wires soldered to it. It's not very pretty, and the connections keep coming loose, so I'm hoping I can capture the data well enough for this project. But I am getting a new one sent in the mail since I think we'll need the sensor for future projects. So it's kind of a messy setup, but seems to be working. You can kind of see how it's plugged in here. I have it attached to 3-volt power. And the Arduino is powered by my Raspberry Pi via this blue USB cable. You can see that's plugged in here. And then my Raspberry Pi is powered by the power bank. So we should be operating wirelessly with my Raspberry Pi set up as a wireless access point. So for my host, I'm using my laptop. I have the video feed here on the right from the camera, and then here on the top I have the yaw, roll, and pitch, and then on the bottom is the GPS data. So hopefully I can demonstrate that the yaw, roll, and pitch changes accordingly. So I'm just gonna get my phone set up so I can start demoing that. Okay, so hopefully I can see that. Okay. Okay, so first I'm going to demonstrate the yaw by just turning the quadcopter, and we'll probably see it go below 0 and then back up above 0. So just do it. You can see that it's going down. Okay, went down to about 300, and we're twisting it back to about 0 or so. Then we'll go over 0. Cool. To about 45 degrees. Okay, so that's the yaw. And now we'll demonstrate the roll. So we're going negative to about 50 degrees, and then we'll go back to positive 50. Okay. And now we'll demonstrate the pitch. So currently, because this is kind of like lopsided with the way the wires are soldered, it's at negative like 4.6 degrees, but that's okay. Okay, so going positive and negative. Cool. So hopefully I was able to demonstrate that I am able to read data from the EN.605.715 sensor for getting yaw, roll, and pitch, and transmitting that data through my Raspberry Pi over Wi-Fi to a host device. Thanks for watching. Hi everyone, this is part 2 of my video demonstration for Project 8, where I am trying to capture yaw, pitch, and roll data from my quadcopter while it's flying. So hopefully we'll get that working with my quadcopter tethered here. While I am flying it, I'm going to try to display all the data on my laptop. So this top window will be the yaw, roll, and pitch. The bottom is the GPS data from Project 7, and then I have the camera feed over in this window. So I'm probably just going to get the screen recording for that started. So I can show that while it's flying. Okay, so I'm gonna get that going, so hopefully we can get this thing off the ground.